Hey guys, welcome back. Sorry about that break there. I'm a type 1 diabetic. I had to do something about my blood sugar, so I apologize for that, and I appreciate you coming back with me. I do want to do a little more practice with solving for K values using KSPs. So let's take a look at this question right here. We have the KSP for aluminum hydroxide is 1.8 times 10 to the minus 33rd. What's the molar solubility? Well, I know that aluminum hydroxide, AlOH3, because Al is 3 plus, so we need 3 OH minus, becomes Al3 plus and 3 OH minus. And that's equal to the 1.8 times 7 minus 33rd, and that's equal to Al3 plus times OH cubed. Okay, so if I set up my ICE table, I can see when I do that I have my AlOH, which I'm not going to consider because it's a solid, and my Al3 plus, which initially is 0, and my 3 OH minus, which initially is 0. I know that for every AlOH3 I break down, I get 1 Al and 3 OH. Okay, so I set that up, and I have my 1.8 times 10 to the minus 33 is equal to x times 3x, and again, that quantity is cubed. Okay, so that gives me 1.8 times 10 to the negative 33rd is equal to 27x to the 4th. So when I take 3 times 3 is 9, times 3 is 27, so that's 24x to the 4th. So I divide by 1.8 times 10 to the minus 33rd by 27, that gives me 6.7 times 10 to the negative 35th. And then I take the cube root of that to get 2.9 times 10 to the minus 9th. That's my Al3 plus concentration, right? Now, if I want my OH minus concentration, I need to multiply that times 3, and that's where I get that 8.6 times 10 to the minus 9th. Okay? Now, my solubility in grams per liter is going to be that 2.9 times 10 to the minus 9th that I solved for, the Al3 plus concentration, times the molecular weight of AlOH3, which is 78 grams per mole, which gives me 2.2 times 10 to the minus 7th grams per liter. Again, here, the concentration of AlOH3 needs to be less than that 2.9 times 10 to the minus 9th, if all of it is going to stay in solution. So if I have more than that, it will precipitate. If I don't, it will stay in solution. Okay? Questions about how we do that? Now, I hope that there are no questions about that. I do think, bear with me just a second, I'm going to flip some slides. I think what I'd like to do is walk through this particular question, because even though I have everything worked out on here, I want to walk you through how I set this up. So I see that it's Ag2CrO4 minus, right? And that tells me that the CrO4 is a 2 minus charge. So I know that it's going to be an Ag2CrO4. It's going to come apart to give me 2 Ag plus CrO4, 2 minus. And you know that it's a 2 minus charge because, one, it's in the table that way, the table of polyatomic ions. But it's also because that Ag is a plus there, and so since there are 2 of them, that means that CrO4 has to be 2 minus, okay? So that's the equilibrium that I'm going to be looking at. Now, if that's the equilibrium that I'm going to be looking at, I know that my KSP is going to be equal to that Ag concentration squared times that CrO4 2 minus. Okay? And that's because those are my products for that reaction that I've written. All right. If I then set up my ICE table, when I set up that ICE table, I know that my initial concentrations are going to be 0. And of course, this is a solid, so I don't actually care about that. I know that for every one of these Ag2CrO4s that I break down, I am going to end up getting 2 Ag plus, so that's going to be a plus 2x, and 1 CrO4 2 minus, so that's a plus x, okay? And so in equilibrium, I know that I'm going to have those things that I can solve for. Now, it also says that KSP is equal to 9 times 10 to the minus 12. So 9 times 10 to the minus 12 is equal to the concentration of Ag plus squared times the concentration of CrO4 2 minus. I also know from my ice table that the Ag2 plus is going to be a 2x. And I have to put that in and then square that, okay? And then multiply that by the x that I get from the other side, okay? So when I do the simplification, I get 9 times 10 to the minus 12 is equal to 2 times 2 is 4, x to the third, because it's squared when I do the square, and then I multiply it times x again, so that's x to the third. Okay? And that is not very clear, so I'm trying to make it more clear. So then I take my 9 times 10 to the minus 12, I divide that by 4, and that's equal to x cubed. And if I do that happy math, I end up with 2.3 times 10 to the minus 12 is equal to x cubed. So I take the cube root of both sides. So on my calculator, if I want to take a cube root of 2.3, I would put 2.3 second e to the negative 12. And then I'd raise it to that little caret. And then in parentheses, I do 1 divide 3. And that gives me that 1.32 times 10 to the minus 4. Okay. I know that's how I do that on my calculator. Now, are there other ways to do that? Yeah, there's a thing in the math. I can get to cube roots in there, and I can also cube it from the math thing, but I don't usually do that. I just use that caret to raise things to powers. And if it's a root of some kind, then it's 1 over that number. So that's how I know what that is. Okay. So that's how I get that my x is 1.3 times 10 to the minus 4th. So the 1.3 times 10 to the minus 4th goes directly into the CrO4 2 minus. That concentration is exactly what I would expect. That Ag, however, has to be multiplied by 2, which is where I get that 2.6 times 10 to the minus 4th. Okay. Now my solubility in moles per liter, the molar solubility is at 1.3 times 10 to the minus 4th. Because that's how much Ag2CrO4 I can put in before anything precipitates. Okay. If I want to find it in grams per liter, I have to take that number, which should be 1.3 times 10 to the minus 4th, not 1.4. Hold on. Yeah. So this number right here should be 1.3 times 10 to the minus 4th. And then I multiply that by the 331.73 that is the molecular weight of ALO8 or Ag2CrO4. And I end up with 0.4378, which of course, if you round it up, is that 4.4 times 10 to the minus 2. Okay. So with the rounding, it comes out exactly the same. All right. So my concentration of Ag2CrO4 needs to be less than 4.4 times 10 to the minus 2 grams per liter, because that's in grams per liter, or less than the 1.3 times 10 to the minus 4th molar. Okay, so those are the two ways that I can look at that. Now, hopefully that makes sense to you. What I'm going to tell you is that just like with any other ice table that we've done, practice is important. So we write these in exactly the same way. We have our balanced equation, we write our K expression, products over reactants. There are no reactants here because that's a solid. So we have our products. Remember to raise them to whatever stoichiometric coefficient is required. We put in our change. For anything that's not a 1 in front of it, we need to have a 2x or 3x or whatever, and then we have to raise it to that same power. So we have to do that for the number that's out in front too. Okay, both are required. So anytime we have a 2x squared, that's going to end up with 4x squared, which we then multiply by whatever else there is. If it's a 3x cubed, then that's going to end up being 27x cubed. Okay, so that's the way that's going to work. I don't necessarily like to make you do huge amounts of math to be able to do this, but if it's just something to the fourth and you can divide by that number, then that is not that big a deal. I typically don't ask you to do anything where both of them are raised to powers and it's all over the place, because that's complicated math. And while I'm sure you can solve that complicated math, it makes it more time consuming to try and do on a test. And that doesn't really help me to see if you understand the concept of what you're supposed to be doing. That's what I need to know. Not that you can do complicated math. Sure you can, but I need to see that you understand the concept of what we're talking about. Okay, so I may ask you to set up one of these expressions. Okay, so that the 9 times 10 to the minus 12th is equal to 4x cubed. Right, something like that. There may be things along that line that you get asked. Okay, so that's the practice that I wanted to do with that. And I'm going to go back and stop this again and start the next section like I was planning to. Hopefully that is enough practice for you. You will get plenty of other practice in the homeworks that you have. And so the Alex homework and the practice questions that you've been given, okay, let me talk about this. So our exam review, which is going to be posted for you, and I think it may already be posted, will include some of this as well. Now, typically what happens with the exam review, the exam covers lectures 1 through 6. So this is lecture 5. Lecture 6 is common ion. So after lecture 6, we will go into lecture 7. We will start lecture 7. And part of what I do in my physical class when I do lecture 7 is a review for the exam. Okay, so I will do that review for the exam separately for you guys, so that there is a separate section that you can watch. That will go through whatever questions I've received about the exam review. I don't always go through all of it because that's for you to do and not for me. It's not important that I know how to solve these things or the questions. I hope to God I can solve them. But it's important that you know how to do them. And so typically what I would prefer to do is to have you guys ask me questions about what you didn't understand from those things. Okay. So given that I'm going to be doing lecture 7 later this week, I would like to have you take a look at those exam reviews and see if you have any questions. Shoot them over to me so that I can talk them through when I do that review. Since our exam has been moved back a bit, if there are other questions that you have, as we get closer to it, that's perfectly fine. Send them to me whenever you have them. I will record something. I will make that recording available to all of our students, of course, but I will make sure that gets posted so that you can see it. Okay. I hope that will help. So we will start new material before the test, but again, what will be on that test will not change. It will be lectures 1 through 6. So up to and including common ion. All right. Well, I will talk to you guys soon. I will be back in our next segment.